Alright, good day everyone, and you are welcome to our chemistry laboratory once again. Today we are going to be looking at qualitative analysis and quantitative analysis within the shortest possible time. Today we want to look at qualitative analysis first. Qualitative analysis is simply the identification of cations, anions, and the evolution of any gases that is present in the unknown substances. And I don't want to waste your time on this, because I believe before now you have several materials with you. Now, against our examination, cations, we have series of cations that we may be testing for their presence in an unknown substance. Take for instance, you call somebody to come and check if there is salt in a particular delicacy or not. That is qualitative analysis. So the same way we want to actually identify if there is a particular cation, positive ion, or anion, negative ion, in an unknown substances. We want to know if there is salt in a food or there is a particular Maggi in a food. So that's just the live example. Now we have series of cations that we can test for. We have aluminium 3 ion, we have lead 2 ion, we have zinc 2 ion, we have calcium 2 ion and copper 2 ion, and the list goes on. Iron 2 ion and iron 3 ion. Now we have reagents that we can use to test for the presence of these anions, of these cations. We have reagents that we can use to test for the presence of these cations. Say for instance, if you want to test if there is salt in a particular food, of course you must use your tongue to test for it. So the testing mechanism that we use to test for these cations are called reagents. Basically, for cations we have two reagents: sodium hydroxide and what? And ammonia. Let me just quickly chip this in. Whenever you are performing the examination in respect to the WAEC standard, make sure you avoid writing symbols for the compounds as much as possible. If you can write the name, you write the name. Until when you cannot write the name of the compound on that test, that is when only you can write the chemical formula. Right, now we can use sodium hydroxide and ammonia to test for the presence of the cations. I've just listed the cations: aluminium 3 ion, calcium 2 ion, lead 2 ion, and zinc 2 ion. All these are white precipitate, excluding aluminium and zinc that are white gelatinous precipitate. All of them are white precipitate, but the first and the last one here are white gelatinous precipitate. Copper 2 ion is a blue precipitate ion that whenever you are using sodium hydroxide or what, or ammonia as a precipitating agent, in some other questions you may be asked, what give examples of precipitating agents? Sodium hydroxide is one of them, ammonia is one of them, and even for anions we have barium chloride, we have barium nitrate, and the rest, and so on and so forth. So iron 2 is usually having a dirty green precipitate, iron 3 reddish brown precipitate. But I don't want to waste your time. I've actually devised a mnemonic device whereby you can actually use to memorize this. All of these, just know their color, the color of their precipitate. These are white precipitate, copper is blue precipitate, iron 2 is dirty green, and iron 3 is reddish brown precipitate. Of course, like I told you earlier on, that we have two basic reagents, precipitating reagents or precipitating agents that can allow us to detect the presence of the cations. Now, how do these cations relate to these precipitates? Ladies and gentlemen, how do these cations relate to the precipitating agent? The point is, memorize this. So far you can memorize this, the rest is a walkover. What is the memorization? Alcene, cane, pepsin, zins, queens, fen square, fen square. Alcene, cane, pepsin, zins, queens, fen square, fen square. Alcene, cane, pepsin, zins, queens, fen square, fen square. The point is, I've just told you that aluminium is a white gelatinous precipitate in either sodium hydroxide or ammonia. However, all this letter S stands for soluble, IN stands for insoluble, S stands for soluble, and IS stands for insoluble. Now the first reagent we are using is sodium hydroxide, and the second reagent is ammonia. In excess sodium hydroxide, aluminium is soluble. In excess ammonia, aluminium is insoluble. In excess sodium hydroxide, calcium is forming white precipitate in drops of sodium hydroxide, but in excess sodium hydroxide, it is insoluble. In excess ammonia, it has no reaction because what you have here is just IN. There is no other thing here. So it is no reaction. Lead is Pb. Soluble in excess sodium hydroxide, insoluble in excess ammonia. Zinc, soluble in excess sodium hydroxide and soluble in excess ammonia. Copper, insoluble in excess sodium hydroxide, soluble in excess ammonia. Iron 2, insoluble in excess sodium hydroxide and insoluble in excess ammonia. Iron 3, insoluble in the two reagents in excess. Now, the point that I've just made is that we have these cations and we can test for them with two reagents. With two reagents, sodium hydroxide and what? And ammonia. And I have just told you that these are the colors of their precipitates. Now, the way you can differentiate them, you can actually differentiate any one of the white precipitates with this mnemonic device. You will discover that this one will have no reaction under excess ammonia. So you may be asked under number 3 question that how do you differentiate any of these cations using any reagent, or you can be asked describe one chemical test to differentiate or to identify the following cations. So far you can memorize this. You can easily recall how to identify the cations.